Welcome to this video series of Cisco UCS Networking, System Architecture and Best Practices, version 3.0. This is an updated and enhanced series from version 2.5, which I posted in the summer of 2010. A lot of this material I created for and presented at Cisco Live Europe in London in February 2011. My name is Brad Hedlund. I'm a technical solutions architect at Cisco Systems. You can find my blog at bradhedlund.com. You can catch me on Twitter, or you can send me an email, bhedlund@cisco.com. If you have any feedback or comments on this video series, feel free to shoot me an email or leave a comment. Would love to hear from you. Thanks. So let's get started with a quick review of the physical architecture of Cisco UCS. UCS is really a single integrated system of switches, cables, adapters, and servers wrapped into one common management umbrella provided by UCS Manager, which runs on the Fabric Interconnect. And at the very center of the switching architecture is the Fabric Interconnect, the 6100 shown here. This is a wire rate 10 gig switch which provides 10 gig connectivity for all of the chassis housing all of the servers. And it also provides 10 gig connectivity or 1 gig connectivity to the upstream data center LAN, as well as fiber channel connectivity to 8 or 4 gig fiber channel to your fiber channel SAN. Now, to access a UCS Manager to configure all of the elements in the system, you can do that through a single management interface on the Fabric Interconnect. And through that single management interface, you can manage the entire system, the configuration of the servers, the configuration of the uplink ports and the server ports, and all of the policies and all the templates, and accessing the single log file which captures all of the events throughout the entire system can be accessed through this management port on UCS Manager. And we would also typically, of course, deploy 2 Fabric Interconnects for high availability and redundancy. So we would have Fabric A and Fabric B, shown here in green and red. And to create that cluster interconnect, we use a special cluster link between the 2 Fabric Interconnects. And these are just point-to-point gig links that are used solely for creating this highly available cluster, for synchronizing the configuration between the 2 fabrics, for synchronizing state information. There's never any data traffic that would ever flow in that cluster link. It's not in the data path at all. It's just in the management and configuration plane. Now, we can have up to 20 chassis today connected into a single UCS system. And in each chassis, you can have half-width blades or full-width blades. And each blade can have a adapter on it, or multiple adapters if it's a full-width blade. And that adapter is dual-ported with 10 gig traces that swing from one port to Fabric A and another port to Fabric B. And the fabric extender that these adapters connect to are really just logical extensions of the Fabric Interconnect they're connected to. There is no console port on that fabric extender. There's no IP address or software image or configuration file that you really need to worry about. It's really a zero-touch stateless device. And as I said, the current supported chassis limit today is 20 chassis. That will grow in the future. That's basically just a support limit. It's not really a hardware limit at this point. And there's a couple of new things in UCS today that are not shown here. There are appliance ports where you can take a NAS filer and connect it directly to the Fabric Interconnect, and there's also storage ports where you can take a storage array such as an EMC or NetApp array and attach it directly to the Fabric Interconnect. I will cover that in subsequent slides. You can also connect rack mount servers as well now to this in addition to blades, and we'll cover that next. One of the new capabilities with UCS with version 1.4 of UCS Manager is the ability now to take a rack mount server, a Cisco rack mount server, and connect it directly to the Fabric Interconnect and manage your rack mount servers much the same way, in fact exactly the same way that you are also managing your blade servers in the blade chassis. So all of these rack mount servers here would be managed through that management port through the same UCS manager interface on the Fabric Interconnect as you were managing all the blades with. So really providing a form factor independent stateless computing. So if you were going to take rack mount servers and decide to connect those to the Fabric Interconnect, this is how it would be done. You would take the CNA ports on that rack mount server. Here I've got a rack mount dual ported. This could be the C200 series or C210 or C250. These are of course Cisco rack mount servers. And I would take that physical port on the CNA and link it directly to the Fabric Interconnect on a port defined as a server port. Now I'm not done yet. I need to create a management plane for this as well, because currently this physical port on the CNA is for data traffic only. So what I would do is I'd take the 1 gig LAN on motherboard links on the rack mount server, and I would connect those up to a pair of fabric extenders, 1 gig fabric extenders. These would be the 2248 FEXs, and this would be for management of the rack mount servers. So I would take the uplink of the 2248 fabric extender and link that to the Fabric Interconnect as well, and define that as a server port. So what I've done here is I've created a management plane for rack mount servers for up to 48 rack mount servers, because I've got 48 1 gig links on these 2248s. So one other thing here too is that the fabric extenders for the management plane for your rack mounts deducts from one of your supported chassis counts. So remember I said earlier you can have today 20 chassis connected to a single UCS system. So when I connect this fabric extender, that deducts from one of those chassis. So I could have 19 chassis with blades, and then I could have one really pair of fabric extenders here for rack mount servers, and that would get me at my 20 supported chassis count. So today again, connecting servers directly to rack mount servers directly to the Fabric Interconnect. We will evolve this capability in the future. This is just the initial offering. In the future, you can expect that you'll be able to take these CNAs and connect them to 10 gig fabric extenders, just like these blades are connected to 10 gig fabric extenders here. It'll look a lot like this architecture inside of the chassis for the blades. And as well, that would also mean that you would not need these 1 gig fabric extenders for the back-end management. All of the management could be done in-band through 10 gig fabric extenders. That's the capabilities that will evolve, but this is how it's going to look initially for rack mount servers.